Hello my dear friends, let's welcome to this live session today on ISRO PYQs discussion for environmental engineering, right? Those who are going to write this ISRO exam, this environmental engineering subject plays a very important role. Let me tell you its weightage in just a few words. See, if you can look at this environmental engineering subject in any competitive exam other than any competitive exam, you name any exam conducted in India, this environmental engineering subject has very good weightage and it plays a role, vital role in scoring, right? In ISRO also, out of 100 marks, you will get 7 questions from this environmental engineering subjects. I am saying 7 number of questions. Recently, also you can look at the environmental engineering weightage. We have 7 number of questions, that too very easy questions. You can attempt all the questions effectively and correctly. Okay, now without any further delay, let's start this live session, ISRO PYQs discussion for environmental engineering now. See, this live session, this 1 hour live session helps you to understand this environmental engineering subject into these various chapters. I have segregated entire environmental engineering into these many chapters. See, if you can take this live session seriously, you can easily attempt various questions based on the environmental engineering subject, right? This session will help you to understand some concepts I have concised, and according to the previous year questions analysis of ISRO, I have taken the questions in such a way that with the help of that particular PYQ, we can also attempt many number of questions. I have given the data like that. So, I am suggesting you to now follow this session seriously so that you can very easily score all the questions asked in environmental engineering. Okay, let's start the questions now. Okay. Now, water supply engineering. Look at this, the very first question asked in the first chapter of water supply, that is population forecasting. Okay, look at this very easy question. According to Indian standards, the consumption of water per capita per day for nursing homes, boarding schools and hostels is. This requirement of water is for commercial and institutional water requirement. If you can look at the question, is specifically asking about nursing homes, boarding school means residential school, as well as hostels. What is the value of that water consumption as per the standards? That is 135 LPCD, that is 135 liters per capita per day, 135 LPCD. See, to remember this particular question, I will give you some additional information so that some extra questions also can be easily answered. See, look at this. You all know domestic water requirement. You know the code which gives the water requirement in India. What is that code? That is IS 1172 1993. According to the IS code, the domestic water consumption for a town or a city, we can have two different values. One is for a full flushing system is 200. You already know this very well known fact. And also for economically weaker section and LIG, low income group colonies, the famous question is 135 LPCD, the most popular question in competitive exams. Right? Domestic water requirement is 135 LPCD. Sir, the question is regarding the commercial and institutional requirement. Why you are saying domestic? Let's wait for some time so that you will be very clear about it. See, I'm giving the value for full flushing system is 200, for economically weaker section is 135 liters. Let me take one more step forward for a domestic water requirement. It is usually accounts 50 to 60% of the total demand for entire water requirement, domestic requirement, industrial requirement, institutional and commercial requirement, compensate losses, all put together. The major contribution is domestic requirement, right? That is 50 to 60% of the total demand. Let me extend another line here. As our IS code, Bureau of Indian Standards has laid down, a limit on domestic consumption is between 135 to 225 LPCD. Remember this fact so that we can identify few more commercial requirements, right? See, why I am saying this? IS code suggests 135 to 225 LPCD. That is, you need to remember. Sir, the asked question is commercial and institutional. Why you have delivered the lecture on domestic water demand? You may think like that. But remember this 135 to 225 for domestic requirement. Let's figure out this board. Requirement for commercial and institutional requirement. If you can look at this, you can see 135 and 225, you can see in many cases in this commercial. I am just giving some tip to remember this commercial and institutional requirement, considering that fact of domestic requirement 135 to 225. Look at this, how many of there? See, if you can look at the residential, right, residential schools also 135, hostels also 135, upper limit just ignore, but hostels also 135. You can see medical quarters or else nursing homes are also 135 to 225, right? You can correlate the information like that. 135 to 225 is domestic requirement, code has given the range. The same value can be adopted here for a residential school, nothing but a boarding school in the question. Hostels also 135, nurses homes and medical quarters also 135 liter per capita per day. You need to remember 135 LPCD for these many commercial establishments also. Another important question is 45 to 90, it is for offices, also for day scholar schools. It is also once asked in engineering services, 45 to 90 for offices as well as day scholars. Need not to remember all the data, you just correlate some data, it will help you to understand some other questions effectively, right? This is about a small question. Based on the question, we have revised these many things, right? That is what my intention to deliver this kind of lecture. Now look at the another question. This is very easy question. Try to answer, my dear friends. How many of you are able to answer? Let me see. See, what he has mentioned, average daily demand is 20, ignore population, it is misleading information given, right? The maximum daily demand is, what is the maximum daily demand? If average demand is 20, the maximum daily demand is 1.8 Q. Nothing but in this question, he has given the average value Q. Q is equal to 20 MLD, he has given, right? 20 MLD is the Q value, average value. What is maximum daily? Q max daily is how much? Q max daily is how much? Q max daily is 1.8 Q, which is nothing but 36 MLD is the correct answer. Very simple, straightforward question, right? Option C is correct. If they ask you maximum hourly demand of the maximum day, what is the answer? Maximum hourly demand. Maximum hourly demand is 2.7 Q, which means 54 MLD is the correct answer. This is for maximum hourly demand of the maximum day, but maximum daily is 36 MLD. That is what the option C here, right? Very easy. Next question. Look at this. The per capita demand of water is calculated in liters per person per year, per person per month, or per person per day. Which is the correct answer? You already know. PCWD, per capita water demand, the total quantity of water required per person per day we evaluate, right? This is what PCWD, right? Per capita water demand per person per day is the correct answer. Option is C. Okay. The next, we just move on to the quality of water. This is what an important chapter. Many number of questions are asked from this area. Look at the first question on chemical water quality. Look at this. The maximum acidity in water will occur at a pH value of, what is asking? The maximum acidity at what value of pH we can experience in natural waters or drinking waters. Tell me which option is correct. You must know the pH scale. Look at the pH scale. If you can draw the pH scale like this, 0, 7, 0, 7 and 14. This is what pH scale of pH. This 0 to 7 is acidic range. You all know this is acidic range of a pH. This 7 to 14 is alkaline or basic range. This is alkaline range of a pH. What happens in this acidic range? In this acidic range, H plus ions concentration is very high comparatively OH minus ions concentration. In this acidic range of pH, it doesn't mean hydroxide ions are absent. Hydroxide ions are comparatively smaller than the H plus ions. This is what acidic range. Alkaline range, you know, OH minus ions concentration is very high than the H plus ions concentration. Concentration of H plus ions is very less in the case of alkaline or basic range, right? See what pH, this is a pH scale, 0 is the pH, move on to this 7 is the neutral, 14 is the base. Now look at the option here. The maximum acidity in water will occur at a pH value of, see, 0 to 7, 0 towards 7, moving on to neutral. Therefore, 0 is the highest value where you can get the maximum acidity of water, right? This is what important question and easy question. Next, the pH value of drinking water should be in the range of, see, the water quality standards as per the Bureau of Indian Standard, the IS code is 10,500 2012. According to that, what is the pH? 6.5 to 8.5, very important Indian water quality standards, right? This is pH value is 6.5 to 8.5. The next one, the desirable limit of chloride content as per Bureau of Indian Standards in water for domestic supplies should not be, should not exceed 250 ppm. Chlorides should not exceed 250 ppm as per Indian standards. Very easy to, you just try to recall from your memory what are the various water quality standards. Next question, maximum allowable concentration of iron in drinking water is, iron also very important. Let me give you a table also. Let's check. This is 0.3 milligram per liter. If you can able to recall, iron concentration must be 0.3 milligram per liter in drinking water. Next one, as per IS specification, Indian standard specification for drinking water, I have already given. This is what an IS code 10,500 and 2012, right? This is IS code once asked in the competitive exam. What is the water quality standard code in India, Bureau of Indian Standard? That is IS 10,500 code, right? According to that, what is the maximum acceptable limit of fluoride as F? Maximum acceptable limit of fluoride. Fluoride acceptable limit is 1 milligram per liter, but permissible limit is 1.5. Let me explain later, but now the answer is 1. Okay, now let me give you this table for your easy understanding, all the water quality parameters at one place, right? See, as I told, water quality standard is given by 10,500 and 2012. According to that code, we have two different limits. One is acceptable limit. This is a requirement of healthy human being, right? The daily requirement for a day-to-day activities. That is what acceptable. Permissible limit. Why do we have this permissible limit? You all studied. In the absence of an alternate source, if the existing source is only one source, we only rely upon that particular source, no other thing we have to do, right? In that particular case, in the absence of an alternate source, we must relax that acceptable limit to some higher value. This relaxation is not, this is not good for human health, but we cannot do anything if the existing water resource is limited for us, right? If in the extreme cases, in the absence of any source, we just relaxation will be given to the acceptable limit. According to this code, we have two limits. Remember that, acceptable and permissible limit. See this, the various limits. You can take the image of this particular water quality parameters. We have few more tables also. Take a screenshot of this. And next one, this we have hardness, chloride, sulfate, fluoride, nitrate. See, acceptable and permissible limit. Permissible limit is little more than the acceptable limit. You can able to see this, right? This is metals. We have solved the iron concentration is 0.3, right? That is what given in this table only, right? From this table, we are expecting one or two questions. Mostly one question is guaranteed from the water quality standards from for any competitive exam. This water quality standards as per the IS code is very important. See, when in the question, if you can see these kind of wording, in the absence of an alternate source, take these values, not this. See, sometimes in the gate once happened this, total dissolved solids concentration as per the IS code, permissible limit in the absence of an alternate source he has asked. He has given that wording, in the absence of an alternate source, TDS value is not 500, permissible is 2000. Don't confuse here. If you can see this absence of an alternate source, take a permissible value from the code. Okay, don't confuse. If not given this wording, you can take the acceptable limit most of the times. Okay, this is once asked in gate, acceptable limit and permissible limit. For any parameter, not only TDS, any parameter. See, alkalinity 200, 600, hardness 200, 600, chloride, sulfate, chloride is 250, sulfate is 200, this is 1000, right? Fluoride 1.5, nitrate is 45, like that. Okay, these are the metals. You need to remember these things. Okay, let me take another question. Okay, temporary hardness, you all studied. What is the cause of temporary hardness in water? Is caused by the presence of what? Presence of bicarbonates of calcium and magnesium, right? This is the correct answer. Need not to explain the simple question. See, we know already calcium and magnesium, these are the multivalent cationic substances which impart hardness to water. These cations in association with carbonates and bicarbonate which impact temporary hardness to water, but the same calcium and magnesium Ca2 plus and Mg2 plus in association with chloride, sulfate and nitrate which impact permanent hardness to water. See, look at this. This carbonate, bicarbonate of calcium, magnesium impact temporary hardness, but the same cationic substances in association with chloride, sulfate, nitrate impact permanent hardness to water. But here he is asking, what is the temporary hardness? Bicarbonates of calcium and magnesium. All the other options are permanent. Sulfates of this, chlorides, nitrates of this impact permanent hardness to water, right? Simple question from your basic memory question. Okay. Look at this list. This is the water quality parameter and concerned health effect. You can see like that. Let's check. First thing, excess nitrates. If the nitrates concentration is more, it leads to, I am taking A, B, C, D here. A, B, C, D. Okay. Excess nitrates leads to blue babies, methemoglobinemia. Right? A is 4. What about B? B is excess fluoride. Fluoride leads to bone related, that is what bone fluorosis is due to excess chloride concentration. Therefore, fragile bones we can match with the excess fluoride. Therefore, this B is 3, 4, 3. Any option? You can simply take option C in exam, but write down. Okay, just listen. Lack of iodide is goiter. That is what 2. What about final one? Excess of chloride. More chloride concentration means saline water. That is also known as brackish water. Therefore, the option is 4, 3, 2, 1. You can just match it to known things to you. Just you can cross check with the options. Don't follow A, B, C, D, all the things. If you can able to answer the question with the help of only 2 options, you can easily take that option and move on to the next in exams. Okay, next. This is based on the biological water quality parameters. See, quality of water is very, very important. That's why I am taking more number of questions from this chapter. Okay, look at this. BOD of safe drinking water must be, for safe drinking water, there is no BOD present, right? That is BOD is 0, nil, right? This is already known, right? There is no life form present in water. Do you expect the drinking water contains some life form in it? No, absolutely 0. That is option A is correct. Now, look at this. This is very, very important question. Most of the times asked in the competitive exams. B. coli or E. coli, Escherichia coli are generally harmless organisms, and their presence in water indicates their presence or absence indicates presence of pathogenic bacteria. He is asking presence in water indicates what? Presence of pathogenic bacteria. If they present, if you can identify E. coli is present in water, pathogens are also present in the water. Why we have relied upon this indicator organism? This is also known as indicator organism. Do you know the properties of this? This is also very, very important. In one of the previous year questions in engineering services also, look at this. See, non-pathogenic indicator organisms are coliform group organisms. Why we have taken this group of organisms? Why? There is certain criteria to this specific group of organisms. They have certain characteristics. If you can understand these characteristics in detail, so that you can understand why we have considered this coliform group. See, these are lactose fermenters. Lactose means, as you know, if you prepare any batter at home, imagine your mother prepared any batter at home. That batter, after we cover with the lid, in the morning you can see the tiny holes at the surface of that particular batter. It means what? It is fermented. Gas is escaped from the batter, means fermentation has done. These coliform group bacteria has the property of lactose fermenters, and another property, it has non-spore forming. Spore is the protective shield for any microorganisms, but this group is non-spore forming. Another characteristic is gram negative. What is this negative positive? See, gram staining technique is to identify the type of bacteria. Gram staining technique is there to identify whether it is a pathogenic or non-pathogenic. Here it is gram negative, right? That is what important characteristic of the coliform. Rod shaped bacteria. This is a rod shaped bacteria. And another characteristic is gas formed within 48 hours at 37 degrees. This is what an indicator for fermentation, right? As I told, these are lactose fermenters. It means they release gas at an optimum temperature of 37. This is another characteristic. This is non-pathogens, non-pathogenic group. These are the characteristics of the coliform group. More specifically in coliform group, we rely upon Escherichia coli. More specific indicator organism is E. coli, Escherichia coli, right? It lives longer and longer than the pathogens and will be more in number than pathogens. That's why we rely upon this indicator organism. If its presence in water indicates presence of pathogens also. If it absent in water, it absence indicates absence of pathogens. That is what we consider, right? This is what important information regarding biological water quality. Okay, move on to the next question. Very easy. This question is also very important. Most of the times asked. Which of the following is not a waterborne disease? Look at this. Dysentery waterborne, cholera is waterborne, typhoid is also waterborne, malaria is not waterborne disease, right? If you can look at this, waterborne diseases, we have a list: typhoid, cholera, polio, jaundice and dysentery. I am not stopping here itself. The list I am just adding one more point. This typhoid and cholera are bacterial disease, polio and jaundice are viral diseases, dysentery is a protozoa disease. I don't want to stop up to here also. Let me extend further. What kind of a bacteria which is responsible for this typhoid and cholera and all those things must be known to you. This is the basic information regarding waterborne diseases. Look at this. Typhoid is due to Salmonella typhi, cholera is due to Vibrio cholera. What is polio? Polio is due to poliomyelitis virus, jaundice is due to hepatitis virus, dysentery is due to a protozoa called Entamoeba histolytica. These are the information you need to know, right? These are all waterborne diseases, right? Very important list. You just go through this list quickly so that you can attempt some questions based on the waterborne diseases. Okay, now look at the plain sedimentation. Very easy. See, if you can look at this, he has given what is the time taken to fill a water tank of capacity at a rate of 20 liter per second. This is small question, very school level bacha question. See, the capacity he has given, the volume of the tank is 2,60,000 liters is the capacity of the tank, and the rate he has given rate of flow. What is the rate of flow? 20 liters per second. What is the time required to fill this tank? That is what detention time you can say. V by Q will give you, to just play with unit. Liter by liter per second will give you time in seconds. Therefore, you can say detention time dt is equal to V by Q. V by Q, you need not to write all these things. You can easily write 2,16,000 divided by 20 will give you 10800 seconds, right? If you can divide with 3600 seconds in an hour, right, you will get 3 hours is the answer, right? That is 3 hours, very easily. You need not to solve much. 3600 divided by 3600, 36 threes, right? 108, 3 hours is correct. Okay, next, a sedimentation tank, the calculation, you must be very careful with the calculation, right? These kind of questions in ISRO, you do not provided, you need not to take any calculator for your examination, right? You must be solved without calculator. Okay, look at this question. Tank has a diameter given, average depth is given, rate of flow is given, the detention period is in hours, detention period in hours. What is the depth he has given? Depth is, diameter is given as 16 meters and the average depth, I am considering the depth as 2 meters, that is average depth. you can write the volume of the tank. Volume of the tank is, it is the circular tank, therefore pi by 4 d square is the area into height h, that is what V, right, cylindrical tank. Just for fun I am considering the pi value 3, but actually not 3, 3.14 some decimal value is there. 3.4 into 16 square, this is 16 into 16 into h value is 2. Now if you can evaluate the volume of the tank, you will get 4 fours 16, this is 64 into 6 will give you 66, 360, 360, 24, 384, 384 meter cube you will get, right. You have taken meters, therefore 384 meter cube is the volume of the tank we got. Now you know rate of flow he has given, rate of flow very easy to solve. The Q value he has mentioned as 5 mld. 5 mld I am converting into 5 into 10 cube meter cube per day, right. 5 mld meter cube per day, meter cube per day. Now what is the time required? The detention time, you know detention time dt is equal to V by Q. Volume is in meter cube, Q is in meter cube per day, therefore you will get the detention time in days, but here the options are in detention period in hours is how much, he is what asking in hours. What is volume? 384 divided by Q value 5000, 5 into 1000. Now 5 sevens 35, 3 4, 5 6 30, 36 76.8, but divided by 1000 means the time in days 0.00768 is in, this is in days, multiply with 24 you will get hours, approximately you will get 1.84 or something in hours, but actually we have taken for ease of calculation, I have considered pi value 3, actual value is 3 point something, little more, therefore volume is little more. If you can correlate the same, your detention time will be more than 1.84 hours, right. The only option here is 1.93 is the correct answer. Option is D. Very easy question. The solution takes some time, right. Very easy. Next, look at this. The most common coagulant used in water treatment plant is, what is the most common universal coagulant? Alum. You know alum, right. Al2SO4 thrice 18H2O. This is the chemical formula for alum. Aluminum sulfate is the universal coagulant, also known as alum, right. Simple question. Okay, next question. Which of the following is a disinfectant method for drinking water? If you can look at the disinfecting method, you can easily answer this question. Chlorination is the only option, that is what disinfection, remaining are not disinfection methods, right. Simple question. Next, this is the very general questions asked from the disinfection chapter. Look at this. Amount of bleaching powder containing 20% available chlorine needed to chlorinate a rural water supply covering a population of 10,000 at a rate of 100 LPCD at 100 LPCD at the rate of 2 ppm. See what he is actually asking, the amount of bleaching powder containing 20% available chlorine. The amount of bleaching powder you need to estimate in kgs. Options are given in kgs. Just look at what is the value of Q needs to be treated. Q is equal to population is 10 to the power of 4, right. That is what 10,000 multiply with 100 LPCD will give you these many liters per day. This is what population. You can think this is 1 mld, right. This is 1 mld you needs to treat. This is what needs to be treated, Q. Now see, if you can look at these question carefully, at a rate of 2 ppm is available chlorine, that is what chlorine dose is adding, that is Cl2 dose is adding, right. Cl2 is 2 ppm, 2 parts per million or 2 milligram per liter, right. Now the quantity, total quantity of total Cl2 required is how much? Total Cl2 required is equal to, see you have a mld, if you multiply mld with ppm you will get kg per day, therefore Q into Cl2 dose will give you kg per day, therefore 1 mld, but the chlorine needed is 2 ppm, therefore See here, total chlorine required is 2 kg per day. This is not your answer. Don't be careful here. Of course, he has not given. If given, you need not to take that as an answer. He is asking bleaching powder containing 20% available chlorine. What is the amount of bleaching powder you need to mix in water to get this dose of 2 kg per day? Total Cl2 I required 2 kg per day to treat this 1 mld of water on daily basis. What I needs to do? I needs to add bleaching powder, not chlorine directly. Right? In that case, he has mentioned 20% means, let me write the point here. 20% means 100 kg bleaching powder. I am writing the bleaching powder in short, right? 100 kg bleaching powder gives 20 kg Cl2. Do you agree with this statement? 20% available chlorine means, if you consider 100 kg of a bleaching powder in which only 20 kg of chlorine is present. If I want 1 kg of chlorine, how much bleaching powder I need? 1 kg chlorine requires. For 20 kg chlorine, 100 kg, 1 kg chlorine requires 100 by 20 kg of BP, right? Kg of bleaching powder I needs to add, right? How much? This is 5 kg of bleaching powder. 5 kg of bleaching powder I need if my requirement is 1 kg of chlorine. But here, according to this 2 ppm of dose, for that mld, for that Q, we need 2 kg per day of chlorine dose, right? For a 2 kg, what I needs to do? For 1 kg is this, therefore 2 kg Cl2 required. How much? 2 kg Cl2 required. Each kg 5, 2 kg is 2 into 5 kg of BP. Therefore, you need how much? 10 kg of bleaching powder. 10 kg of bleaching powder. Very easy question, right? Okay, just to correlate the percentage of bleaching chlorine present in the bleaching powder is the key point here, right? If he mentioned 30%, 100 kg gives 30 kg chlorine. Each kg of chlorine needs 100 by 30, like that. If your requirement is 1 kg, this is answer, but your requirement is 2 kg chlorine on daily basis. Therefore, your requirement of bleaching powder is 10 kg on daily basis you need to add to your treatment plant. Answer is 10 kg. Option is Ahmedabad, A. Right? Very easy, simple question. Don't confuse. Now, next question. We have discussed water treatment also. Now, miscellaneous treatment. Look at this. The permanent hardness of water can be removed by. Look at the options carefully. Here, alum, adding alum and adding chlorine are no way related to hardness removal, right? Therefore, these options you need to eliminate. Easily, you can eliminate that. Boiling removes hardness, but permanent hardness removed by zeolite process, not boiling. Boiling removes temporary hardness, right? Zeolite process or ion exchange process will remove permanent hardness from water, right? This is what important question. Next, okay, look at this water softening methods. We can see boiling, I told, temporary hardness removed, that is water softening. Lime also removes temporary hardness from water. Lime soda process removes permanent hardness, but zero hardness cannot be achieved by lime soda process. Only we can achieve by ion exchange process, or zeolite process can only remove complete hardness from water, zero hardness, right? Ion exchange process. But one thing is, boiling and lime treatment removes temporary hardness from water. Lime soda permanent hardness, ion exchange also permanent hardness from water, but zero hardness can only achieved by ion exchange process. Okay. Next, which of the following treatment reduce the salinity of water? You know, if you can look at this, sedimentation, filtration and chlorination, they don't remove salinity from water. Only thing is RO, reverse osmosis, or membrane filtration techniques. Reverse osmosis is membrane filtration, right? That is this question. Okay, look at this, some desalination of water methods. RO is a desalination process. We can remove salinity from water. Electrodialysis is also desalination. We can also do distillation from sea waters, will get pure water. That is what some desalination methods I have listed out here, important methods. Okay. Next question, wastewater. Water supply we have discussed, right? If you can look at the variety of questions asked in the ISRO exam, you can see very easy, right? You can easily answer all the questions. Theory questions are also easy, numerical also very easy. You can play with the units, nothing more than that, right? Easy to score. Utilize this subject for scoring in your any competitive exam. Okay, wastewater engineering. look at this, a manhole is generally provided. Tell me, the manhole is generally provided at each bend and junction and change of sewer dia and also change of gradient. In all the cases we do provide manhole. See, if there is a transition between the one sewer to another sewer, there is a change in direction of sewage, we need a manhole there. We cannot connect that elbow for our water supply, right? Water supply smoothly can be conveyed by providing an elbow for change in direction. 30-degree elbow, 90-degree elbow, any degree of elbow can be provided, but sewage we need a manhole, right? If you can look at the change in diameter is needed. Whenever the change in diameter needed, we need a manhole here, not simply connecting and coupling like a water supply means. We need a manhole to join both of them. Another case, change in gradient. One sewer is on higher elevation, another sewer is at a lower elevation. We must connect them by providing a manhole. Ramp, if you can construct a ramp, we cannot take the sewage smoothly, right? Therefore, all the above are correct. All the above are important cases for providing a manhole, right? Next, sewers. This is one of the popular question. You already know self-cleansing velocity, right? What is self-cleansing velocity? If you can look at the options, you may have some doubt, but please read this question carefully, otherwise you may commit a mistake, right? Look at this. Self-cleansing is the maximum velocity? No, it is a minimum velocity. It has mentioned maximum, you need not look at that, right? It is the minimum velocity of flow. Sorry, option A I am reading, maximum velocity of flow required to maintain certain solids in the flow. No, we need to have a self-cleansing effect. Self-cleansing means auto-cleansing. Whatever the deposited solids which are present in the sewage, we must have an auto-cleansing effect, right? That is not a maximum velocity, minimum flow velocity, right? Therefore, the minimum velocity of flow required to maintain certain amount of solids, no need to maintain, flush off, right? Such a flow velocity as would be sufficient to flush out any deposited solids in the sewer. This is correct, right? Any deposited solids, that is what flush out is needed, right? Option C is correct. Please read the statements. Don't only try to apply the definition you have studied, right? Please apply the logic behind the self-cleansing velocity. Such flow velocity as would be sufficient to ensure that sewage does not remain in the sewer. Sewage remain in the sewer only. Sewage will flow within the sewer. Sewage remains in the sewer only, but in flowing condition, right? Therefore, option C is the correct answer. Next, look at this characteristics of sewage. These questions are very common on BOD, right? See, if the depletion of oxygen is found to be 5 ppm after incubating a 2.5% solution of a sewage sample for 5 days at 20 degree, standard is given, 5 days 20 degree incubation period, he has observed a depletion of oxygen. Be careful here, he has not given initial DO, final DO, he is saying the depletion of oxygen is found to be 5 milligram per liter or 5 ppm. Depletion means from initial value to the final value in a 5 days. The depletion happened is 5 means initial minus 5, final is 5 ppm. Directly he has given. Again he has given 2.5% solution is incubating, means dilution factor. If you can look at, let me take depletion means DO initial minus DO final. DO final value is 5 milligram per liter. That is what meaning of depletion. Now dilution factor, you know, dilution factor is 100 by percentage dilution. Percentage dilution is 2.5%, right? 2.5% means 100. What is the dilution factor now? Dilution factor is again 25 force. 200 by percentage dilution, right? 2.5%, 100 by 2, sorry, that is a mistake here, sorry. You just take a 2.5, that is, I'll write the formula, otherwise you may confuse here. Let me take the formula now. The dilution factor is saying whenever the percentage dilution given, 100 by percentage dilution is the formula to get the dilution factor. Directly take 2.5, don't convert that into percentage again. That is the mistake I have done. 100 by 2.5 is the correct. 2.5 means 40 you will get, right? 40 is the dilution factor. Dilution factor is 40. Now what is the BOD of the sewage? BOD of the sewage, you all know BOD 5 day at 20 degrees centigrade is initial minus final into dilution factor, that is given already 5 into dilution factor is 40, you will get 200, right? 200 milligram per liter is the BOD here. Very easy question. The option is D, right? Correct. 200 is ppm. Don't worry, the small mistake I have given, but here 100 by percentage dilution. Take the value directly. Don't change 2.5%. Okay, next question. See here, if the depletion of oxygen is found to be, again given depletion only 2.5 milligram per liter. Depletion means initial minus final only, right? Incubating 2.5 ml of sewage diluted with 250 ml of water. Don't think BOD bottle capacity is 300 ml, but he has given 250. Use the given data in any competitive exam. Don't take your own data. Already standard data is there, but here he has mentioned incubating this 2.5 ml of sewage. Sample he has taken 2.5 ml of sewage. He has diluted with 250 ml of water for 5 days. Means what is the dilution factor? 250 divided by 2.5 is the dilution factor. The 2.5 ml is diluted to 250 ml. How many times you will get? That is 250 divided by 2.5 means 100, right? That is what dilution factor. 100 into 2.5 will give you 250 milligram per liter. Without even taking the calculation, you can also answer. I am writing directly BOD. I hope you understood. BOD I am writing depletion of oxygen is found to be 2.5, means initial minus final is 2.5 into dilution factor. You know another formula of dilution factor you studied, 100 by, just now I told 100 by percentage dilution is the one dilution factor formula. Another formula is capacity of the BOD bottle. Here mentioned 250. Therefore, I am writing just capacity of BOD bottle. Capacity of BOD bottle. All the time may not be 300. Here you need to take capacity of BOD bottle by volume of sewage. Here he has mentioned how what? 250. Therefore, you need to use these two formulae for dilution factor. Here 2.5. Here what is the capacity? 250. Therefore, 250 divided by 2.5 will give you the answer as 250 milligram per liter. No need to take these many steps. You can directly take 250 is the correct answer, right? Next question. See, similar questions are asked in BOD characteristics of sewage for this ISRO competitive exam. Look at this. If the depletion of oxygen is found to be 3, after incubating 5 ml of sewage diluted to 250 ml, means 250 divided by 5 is the dilution factor. 250 divided by 5 means how many times that 5 ml is diluted? 50 times. 250 divided by 5, 50 times. 50 into 3, 150. Directly you can take 150 milligram per liter. I hope you have understand this, right? I'm not taking steps. We have solved similar questions like this, right? 5 is the DO, initial minus final. Multiply with 250 by 5 will give you 150 milligram per liter, right? This is the answer. Okay, next. This is also one of the important question from population equivalent, from characteristics of sewage only. Look at this. If the average sewage from a city is 95 mld, 10 to the power 6 liter per day, and the average 5-day BOD is 300 milligram per liter, the population equivalent of the city is how much? He is given 5-day BOD per capita at 20 degrees, these many kg per day per capita. That is what meaning, per person per day, these many kgs he has mentioned. Now, what is the population equivalent? You know, the population equivalent means the total BOD. What is the total BOD? Total BOD is equal to, we can say total BOD is equal to Q. What is the Q value given? Into what is BOD? That is YI. This is what total BOD. Q value is 95 mld. 95 mld multiply with 300 milligram per liter will give you kg per day. I don't solve this. This is kg per day. What I have done? Q is in mld. 95 into 10 to the power 6 liter per day means 95 mld multiply with 300 milligram per liter will give you these many kg per day. This is the total BOD. The total BOD also we can write like this. Total BOD means, you know, here we have per person BOD. what is that per person BOD? 0.075 kg per day per capita is given per capita at 20 degree. That is what per person BOD, that is 0.0775 kg per person. This is the population per day. If you multiply this with the population, what you will get? You will get the total BOD, same kg per day. This is the population, multiply with the population, right? PP cancel, you will get the total BOD. Are they same? Are they same or different? Look at this. This is the total BOD, 95 into 300 kg per day. This is also total BOD. If you can equate all these two, you will get the population equivalent. Now 95 into 300 will give you the total BOD in kg per day, 0.075. 0.075 into population P. We can say this is the what? Population equivalent, right? What is the population equivalent? The population equivalent is equal to 95 multiplies 300 divided by 0.075. 0.075 means 75 by 1000, right? This is what the answer, right? 25 3 is 75, 25 4 40, right? If you can go through the solution, this is 100, you will get 95 fours, 3,000, 3,80,000 you will get. If you can solve, you will get 3,80,000 is your answer, right? Look at this, 360 plus 20, 380. Therefore, answer is what? 3.8 lakh is the population. Very easy question, right? Okay, next, treatment of sewage. If you can look at this, the sewage treatment units in which biological decomposition of organic matter takes place are called. Look at it very carefully. The sewage treatment unit in which biological decomposition of organic matter takes place are called sludge sedimentation tanks, trickling filters, Imhoff tanks, none of the above. From the given list, if you can identify in which biological decomposition of organic matter takes place, see in the both the units, trickling filter biological decomposition of organic matter takes place, as well as Imhoff tanks. Imhoff tanks are two-story tanks. Upper story is for settling of solids, lower story is for decomposition of these solids. Therefore, this question is, for my perception, it has two options. But however, we can say we can provide two options only, but only one appropriate answer is correct. Maybe this question got eliminated, I don't know. Okay, let's look at another question. Removal of oil and grease from sewage is known. Removal of oil and grease from sewage is known. What is that? Skimming, right? The oil and grease can be removed by skimming technique, right? What is screening? Screening removes large floating substances from water, right? This is the treatment question. Now, activated sludge process. This is very common question from F by M ratio. If you can look at this question, an ASP is 30 meter long, 9 meter wide and has a liquid depth of 4 meter, given length and width and depth 39 4. This is the dimension of the ASP, right? Aeration tank. The influent sewage flow rate is 3.5 mld. This is influent sewage flow, QI. The primary effluent has a BOD of 130. That is what an primary effluent means. The effluent after the primary treatment, that is what primary effluent. This is influent to secondary treatment, that is what 130, which enters the sewage treatment, ASP. And the suspected load is a load of 15 milligram per liter. The MLSS concentration in the aeration tank is given as 1800 milligram per liter. What is the corresponding F by M ratio? You all studied F by M ratio, right? What is F by M ratio? F by M ratio. F by M ratio is food to microorganisms ratio. What is food? Which is present in the aeration tank. Q into Yi means what is the flow which is entering the ASP multiplied with the BOD with which it is entering will give you food to microorganisms. Microorganisms means V into X. This is what F by M ratio, right? Food to microorganisms ratio. Okay, what is Q value? Q value here is 3.5 mld, right? This is 3.5 mld means 10 cube liters per day, right? Million liter per day, mld is given, 10 to the power 6 liter multiply 10 to the power minus 3 will give you 10 cube liter per day. This is liter per day, mld into yi. What is yi? The influent primary effluent has BOD means yi influent to that is 130 milligram per liter. This is 130 milligram per liter, right? Divided by, what is the volume of the tank? 30 into 9 into 4. 30 into 9 into 4 is the volume. 30 into 9 into 4. See, 3.5 10 to the power 6 liter into 10 to the power minus 3 means these many meter cube, not liter. This is meter cube per day. Sorry for that. This is meter cube per day, right? This is volume in meter cube. I have indicated V. What is X? X is MLSS is 1800, right? This is 1800 milligram per liter. Milligram per liter. Now, if you can evaluate, you will get the day inverse as F by M value. What is the F by M value you will get? If you can solve this, you will get the F by M value close to 0.24, I think, right? 0.24 or 0.56. Let me evaluate. You will get 3.5, 10. Therefore, this is 35 into, let me take 10 here, 100 into 130 divided by 30 into 9 fours, 36 into 1800. For just for fun, I am taking 35. Ignore, this is 36 only actually, but I have removed that. Now you can take this 100 30 into 10 cube divided by 18 into 3, 54. 54 into 10 cube. Therefore, you are getting finally 13 by 54 is the answer, right? But actual value is here 36, but we have considered 35. We have taken lesser value, you will get the more value, but little lesser is your F by M value. This is what F by M value you will get, right? This is the value. I think you will get 0.46, right? 0.24 or 0.46, 13 by 4. 2.24 is the correct answer, right? 54 means 0.24 you will closely get, but the lesser value is 0.23. That is what B option. Okay, next value. Next question, very easy question. See, in a sludge digestion tank, the gas that mainly evolves is, in a sludge digestion tank, the major gas is methane only. In a sludge gas, the major component is methane. Hydrogen sulfide is present, nitrogen is present, ammonia is present in a sludge gas, but the major gas is methane. Look at this, sludge gas contains, most of the gas contains up to 70% is methane, 30% is carbon dioxide, and the remaining other gases are trace gases like nitrogen gas, H2S gas, right? This is what composition of sludge gas, right? The next question. I think this is the last question today in this session of ISRO PYQs. I have taken this air pollution and control. These kind of questions they may ask from air pollution chapter by considering this previous year gate question, right? You can see the primary, secondary air pollutants very carefully. Most of the times they may ask questions based upon the primary, secondary. He has given 4 common air pollutants found in the urban environments. He has mentioned the 4. Among these, which is the secondary air pollutant? Look at the options given: sulfur dioxide, NO nitrous oxide, and O3 ozone, and then soot. Soot means that is what a diesel soot, that is what kind of a particulate matter. Therefore, whatever the given things in that list, ozone is the secondary pollutant. He is asking for secondary. Therefore, ozone is the correct answer, right? Okay, this is the air pollution chapter. With this, we have covered almost entire environmental engineering through these various PYQs asked in your ISRO exam. I hope this session helped you somehow to your preparation, right? I think you can able to recall from your memory these kind of various questions, right? Very easy questions. The subject is a scoring subject. Please pay enough attention to this environmental engineering so that you can have the edge over the other students, right? If you can score all the questions, if you can attempt all correctly, you will have some edge over the other students, right? Very easy chapters. Okay, I wish you all the best for your upcoming ISRO exam. Thank you very much. Goodbye.